Remember a while ago we looked at a graph like this, and I put the unit circle on the left and I put a function graph on the right. We did this to graph sine and cosine. And I put the circle on the left so you could kind of see that as we ran around the circle, it traced out a wave on the right side. You with me? Well, you could really look at this as the Ferris wheel on the left side. Now, when you start out on a Ferris wheel, do you always start out at the bottom? Answer, no. Now, I understand that's where you get in the ride. Nobody jumps into a Ferris wheel at the top. So I understand everybody walks in at the bottom. But that's not when the actual ride begins. They have to load all of the cars first, right? So when the ride starts, right, that's when the clock is at 0, right? You could be in a variety of locations around that Ferris wheel. But you are not guaranteed to be at the bottom. I understand some of you think that you're going to always be at the bottom. That's only where they load people in. Okay. If you are the last one loaded, that's true, you would be at the bottom when the ride starts. I don't think this equation is going to show us that. Okay? So we're starting with this. Can you put it in fireproof form for me? Go. Put it in fireproof form. No, this is a different problem. I want you to hold on to that one. Okay, I want you to do this one in your notes. Okay, the worksheet is for later. You can work on that next week. I'm going to do similar problems to what's on the worksheet so you have some notes to go off of. So what'd you put on the left side? D minus 45 over 40. Cosine. What did you do there? Ah, good. You multiply the top and the bottom of that thing by 60 over pi. Excellent choice. Now, why would you do that? So that you could get t minus 15 on top, right? Because this, and this, and this, and this cancel out. And what's on the bottom? 60 over pi. There's your fireproof form. Okay. A, B, H, and K. Figure out what A, B, H, and K are, please. What's A? 60 over pi. How about that B? 40. H? 15. K? 45. Tell me what the radius of the Ferris wheel is. What part of the wave? You know you're going to be drawing a wave like this, right? On your function graph. What part of the wave goes with the radius of the Ferris wheel. Amplitude, thank you very much. So, I like that thought. Do we know the amplitude? So you know the radius. Radius of the Ferris wheel is 40. Right? Because the middle of the wave, right, that's the center line, is the middle of the Ferris wheel. So the radius would be the amplitude, because you're going to go up, and then you're going to go down, and then you're going to go up. Okay, so that makes sense. So radius equals amplitude, which equals 40. Okay. Let's see here. How high is the center of this Ferris wheel off the ground? How high is the center of the Ferris wheel off the ground? Let's hope it's more than 40. You know why we hope it's more than 40? Otherwise, the Ferris wheel does this. Every time your car comes to the bottom, that's horrible. Especially if you're. What if this one of those Ferris wheels where your feet dangle out, man? It's a lot of blood. Let's not do that. Let's not do that to these people, folks. Pull your feet up. We should have them. It should be like where it goes underwater and then comes back up. Okay, this might be a small torture device. How high is it? The center of it? If it's more than 40. 45. Thank you very much. It's the center line of the wave, right? The center line of the wave. The K value is the distance off the ground. So the K value is 45 feet. Can you answer letter C right now? What is the maximum height above the ground you would reach? I've heard a lot of answers. I hear 45, 85, 90. Well, we know it's from the ground up to here is 45, and then if you add a radius of 40, that would be 85. Those of you who said 85, nice job. Actually, yeah, in your notes, that worksheet is got different numbers on it, so you'll have to work through that. Okay, now, what's the low point? What's the lowest point that you will be off the ground when you're on this ride? 5 feet off the ground. Usually there's like a ramp or a set of stairs to go up to where you get onto the ride. So we're 5 feet off the ground at the lowest point. Okay? At the start of the ride, does anybody know what the time is for the start of the ride? Time is equal to 0 seconds. Good idea. How high is the person off the ground? If I were you, I would use that equation. Now, I don't care if you use the original version or the fireproof version, but you probably better figure it out. And I think I would make my calculator be in radian mode if I were using the machine.
Oh, the 1A.
Oh my. Okay. Never leave your weapon of math instruction. sure your calculator's in radian mode when you type in your 0 and go through the process of solving for the D.
Yeah, exactly what I'm doing. That's a problem. Until someone tells us.
You can use either equation. You can use the fireproof form, or you're talking about this 60 over pi right here. Oh, no, that was part of the denominator of this, so let me circle it in a different color. Yeah, you're right, that might be a tad bit confusing. I got over 70 feet. What'd you get? 73.3 would work. Okay. So when we started, we were 73.3 feet off the ground. Obviously, we are not at the bottom, folks. You know what? Do me a favor. Before we answer B and D, let's graph this thing. Graph the function. Maybe we need to know the period. Does anybody know the period of the function? What's the period of the function? I probably should write that a little bit smaller. Those are like giant letters. How do I find the period? Multiply your A value by the original period. Boy, if we only knew the original period of a cosine wave. 2 pi. Oh, okay. Yes, yes. So we had 60 over pi times 2 pi. 120. Now I think the pi's are gone. Can you answer letter B? How long does it take the person to make one complete revolution? 120 seconds, doesn't it? Oh, that's right, because that's the period of the function. The period of the wave and the period of the circle are the same. Okay. Where's HK? 15 comma what? 15 comma 45. So as you can see, I made up that is 15 seconds right there. It's on the K axis there at 45. K equals 45, the center line of the wave. We're dealing with the cosine function, folks. That point right there, is it on the wave or under the max? Under the max, right? Okay. So we know that the first point of the cosine wave is right there. How far to the right should I go before I find another point where it starts the cycle over again? 120 seconds, right? So, yeah, I'm kind of making this up, folks. We know it's 120 seconds, so let's see, that would be, the distance is 120, so this would be 135, right? Okay. We're back at the top, right? Halfway in between, where are we at? We are at the bottom of the wave, thank you very much. And halfway between 15 and 35, well, let's see, what would that be? So 75? Is that right? 60 seconds away, yeah, 60, yeah, that would be right, 75. And then, of course, you can put your other parts here and you can draw your wave. Oh, by the way, where should I connect it with the x-axis or the y-axis there? What is that value right here? I didn't do a very good job, by the way. 73.3, thank you very much. The y-intercept is 73.3. You just figured that out for letter A. So this little dot I did a bad job of drawing is at 73.3. Not drawn to scale. Like, yeah, because all the geometry teachers get away with that crap. Okay, so now, answer D. If the ride lasts for 9 minutes, find all the times. Now, it doesn't say how many times. It actually says find all the times that the person would be at the maximum height. Can you name any of them? 2 seconds? 15 seconds. That better be one of the answers you have written down for this question. Right? Because the first time you hit the maximum height was 15 seconds after the clock started. Oh, now you're putting 2 and 2 together. Nice. Okay. So what's the next one? 135. You might want to write that down too. Now, 9 minutes. How many seconds are there in 9 minutes? 540. Thank you very much. You need to figure out all the times when it reaches the maximum. We know 15 and 135, but there might be more. Go. Find them. So I got the 15 and the 135 and the 255 and the 375 and the 495. What about 615? Nope. That's over the 9 minutes of the ride. So 255, 375, and 495 were the only remaining times that I need to add to my list. 255, 375. 495. Any questions about this? Yes. Sure. So really you're focusing on what's inside those parentheses that was like this. Now, what I have taught you guys to do is to realize that the whole thing can be divided by 1. And fireproof form dictates that you have 1t. Now, the reality is I could have distributed the pi over 60 inside the parentheses, but I thought that would get a little bit messy. So I didn't. Okay? So I could have done that. Pi over 60, t minus, what is 15 over 60? That's 1/4. So that would have been like pi over 4. I could have written it like that, but I decided not to. Okay? So the goal is to get rid of this thing right here. So what would you multiply by that to get rid of it? You would multiply by its reciprocal, 60 over pi. But if you do it to the top, you got to do it to the bottom. And that gets rid of that. Does that make sense? That's kind of the strategy we were using, just like we did when we were working on that part of the chapter before. Anything else on this Ferris wheel example? Yeah, the Ferris wheel is now on fire. Okay. Anything not make sense about finding the period, the amplitude, how everything's connecting to from the wave to the actual circle of the ride. Okay. You all need your graphing calculators out for this next part. We'll pick something different then. You can actually use the back side of that worksheet because I'm going to pick a different group of numbers than the average high. We're going to go with average low. Okay. So for our notes, we're going to go with average low. Now, I wouldn't write what we're about to do on your worksheet because your worksheet is going to ask you about average high. We're going to focus our attention on average low for the notes. Okay? So you'll need to... I'm limiting my data so that we don't have to type a whole bunch of things here. Okay. What do you think what kind of numbers should we use for these? 1 through 12, right? So that would be 1 and 2 and 3 all the way down to 12. What if I gave you a question where the data went January, March, June, July, October? January, March, June, July, October. 5 months. Would you number them 1, 2, 3, 4, 5? Please tell me no. Okay, please actually use the number of the month that it is. So if it's March, please call it 3. Just because it's the second one in the list, don't call it a 2. Alright? We have all the data here, that's why it's easy to see 1 through 12. But if you're given an example where you have limited data, please just number out the months the way you know they should be. Okay, so go to your calculator. We got list 1 and list 2. Time to enter some data in your calculator. For those of you who do not remember or recall, we have to hit stat enter to get into our lists. Stat enter. Has anybody actually deleted their lists or accidentally deleted their lists and needs to get them back? Okay, just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 17, 19, 28. Make sure everybody's got the data entered in, right? Just doing average low. Average low. You save your average high for when you do that worksheet. Please make sure you do this work on a different page so you can use the average high temperature for this page. So make sure you're putting your work in your notes somewhere. Everybody got the numbers entered in? List 1 and list 2? Okay. So, we would like to make a scatter plot. Okay. Now, scatter plot, that's up here. They abbreviate it stat plot. I think primarily because scat plot would be something completely different and extremely gross. Okay, evidently not. Okay, no animal lovers out there? Okay, seriously. Okay, yeah, I know. Missed that joke. Whew, swing and a miss. Okay, so if you go to the stat plot feature, make sure you select one of the graphs and use the switch to turn it over to on. We are using not the first one, but the second one over. The second one over will actually connect the dots. The second one over will connect the dots. We do want to be using list 1 and list 2. So make sure you have switched it to on and you have the second graph which connects the dots in list 1 and list 2. Okay. Now if you hit graph, I guarantee you my picture's going to look horrible. Okay. I mean, look, we got that, let's see, can you tell me right now if that's secant or cosecant? I know, nothing shows up for you. We'll get to that in a second. I want you to tell me what you think is secant or cosecant. I'll give you a hint. That's got to be cosecant, doesn't it? Because what I'm drawing is a sine wave. So since this is a sine wave, that means this is a cosecant graph. I'm just checking. I know we don't need that. And I'll clear that out here in a second. Zoom. Which zoom do we need? Not standard. That'll take me to the -10 to 10 window. Zoom stats. Number 9. That is, if I ever make my own cologne, that's what I'm going to call it. Zoom number 9. It's not just for men. Okay. Yeah, we got commercials. I got it all. Does it look like a sine wave to you? Kind of. It's got the shape. It's definitely not a parabola. True. It could be an upside. It could be a cosine wave. True. Yeah. But it's of that same family variety. Okay. Let's freeze this for a second. Sorry. I pinged Julian on there. I had to use him for a logarithm video. Sorry. For the song in Madagascar that he sang about the coefficient to exponent property where you could move the exponent back and forth. I like to move it. Okay, that's all about that coefficient and exponent property of logarithms. So I was teaching my Algebra 2 kids about that, so I had to throw it in the video. Anyway. Let's see, custom pin. Let's go yellow. What's the period of this particular wave? What's the period of this particular wave? In other words, I need you to think about this question. How long does the average low temperature take to complete the cycle and start over again? 12 months. Thank you very much. Okay? 12 months. Now, that is enough information to help me find A. Because as one of you said, we know the period is 2 pi times A. So, tell me what A is. Don't say 6 pi. 6 over pi. You are correct. Because if you divide that by 2 pi, right? Take the 12 and divide by 2 pi, you do get 6 over pi. Okay? So now we know the period, we know the A value. We're getting closer to an equation. Can you help me find the center line of the wave? Can you help me find the K value? What is the lowest low temperature in your data. 17, what is the highest low temperature in your data? 63. So if I average them together, wouldn't I get the middle? What would that be? 40? Go to your y equals right now. Hit your y equals button. And type 40. Go back to your graph. It draws the center line, doesn't it? Okay. Oh, it didn't. Stop doing that. Okay, so we got a line through there. What's the amplitude? What's the amplitude? How'd you get 23? If you took the maximum and subtracted the center line, right? Max minus the center line, you end up with the amplitude. Now, what part of my equation is the amplitude? That's B. So now we've got A, we've got K, we've got B. What's the only thing left? H. Now, in order to know what H is, I have to know whether I'm dealing with a sine or a cosine wave. I will tell you that we're going to do a sine wave. So we're going to be putting all this stuff together into a sine function. So I don't care if you write it in fire proof form like y minus 40 over 23 equals the sine of x minus something divided by 6 over pi. Well, we got to figure out what goes inside there. Maybe I didn't give myself enough room. If it's a sine wave, where do you find HK? Do you find it under the max? Do you find it on the center line on the way up the hill? You find it on the center line on the way up the hill, right about there. This is the only part where you're going to need to estimate. So, I'm going to switch back to my other screen here. When you hit the trace button, please make sure that you are on not the plots. We don't want to be on the plots because every time you move the arrows, you're just going to jump around from point to point. I want to actually be on the line, so use the up arrow or down arrow to sit on the horizontal line. And now, get over here close. Get over there where you think H is. You put your dot where where that line is crossing the curve. You estimate. There are a few of you that are going to get the same value, and some of you that are going to get a slightly different value. But guess what? We're estimating. This is the only part where I'll let you estimate. I'll give you my estimate, 4.1. That's my estimate. What did you get? 4.2? I buy it. I buy it. Because it's an estimate and we're both real close. So, if you estimated 4.1 and the person next to you estimated 4.2, it's okay, folks. It's okay. That process right there you're going to need to be able to do. Yes, I used the graphing calculator to do the graphing. But the one thing I didn't do is sine regression, which we're about to do here in a second. Sine regression will give me the most accurate equation. But guess what? It's not going to look anything like that. Yeah, there might be a few parts of it that look familiar to you. And it will be the most accurate. This right here is close. but it is not the most accurate. Now, if I ask you to do this process on the test, and you use sine regression and cheat me out of all that work, you lose. So, let's do the sine regression. So back on the home screen, Stat, Calc. Which one of these should I use for sine regression? Oh, the one that says sine regression? Excellent choice. I don't know what iterations means. I'm going to have to look at that to see if that needs to be changed or messed with. Not sure. You would think it would be sine regression. A period would be 12 months, I would guess. Let's hope The old style calculator didn't ask you to do that, so I'm not really sure. Now, you'll notice that their equation is not written in fireproof form. In fact, their equation is written in a much more different form. So, they have A. Now, if I were to try to manipulate this into fireproof form, which, folks, this is my least favorite way to write this equation. Their A value is what for me? That's my B. That's controlling the amplitude. And we said that was what? Amplitude was 23. Well, ding, ding, ding. It's 22.9 if you want to be more exact. My K value is what they're calling D. We said that was 40. They got 39.8. You might not be able to tell the H and the A value when you look inside those parentheses because of the way they have written it. They went with the decimal form of that. Now, this is the most accurate equation. Could we use that equation to get a prediction on the average low temperature? Yeah, we could. And we could plug in a month. Now, I could do the exact same thing with the one that you created. In fact, I will do the same thing. I'll say, what does your equation predict for? And I might say September. What would you plug in for September? 9. You would plug in a month of 9 for September. Now, look at this data on the page here that you guys are going to work on. You're going to work on average high temperature next week, or as you continue working this week. Is 85 anywhere in this list? Okay. I noticed down here it says, what month would your model predict to have an average high temperature of 85? Now, in your equation, where would you put 85? Is that your X value or your Y value? That's the Y value right there. Well, if you plug in an 85, guess what? I know we're leaving. You'll end up with, they actually goes above your waves, so that's impossible. I just don't want you to get angry at me when you're working on this week. Because you're like, how come that doesn't work? Well, there's a reason it